and I work with the Kenya Meteorological Department as a meteorologist or a forecaster, if you like. And in the last about 6 or so years, we've been running a flood early warning system, initially under a project called Twiga, but currently under TEMBO or TEMBO Africa. And basically, we've been focusing on basin-wide forecasting. And here with me, I am with Mark, who is with the HCP International, and also Frank Arno from the Delft University of Technology. And of course, I have a host of other project members that we work with, as you shall see later. So basically, I shall present what you see outlined here in terms of just an overview of what the flood early warning system we run here in Kenya entails, and also will show you with regard to the structure, the other activities that go alongside the flood early warning, such as the capacity building activities that we've been doing. And of course, we'll also show you some of the outputs or the results from our project, and of course, lessons and way forward as we move. So as you have already mentioned, is that we are implementing the flood early warning system under the TEMBO Africa project, which actually is a consortium of several countries in Africa and in Europe and elsewhere. But here in Kenya, we're focusing on two major basins in Kenya, and particularly that they started way back in 2018 when we started off with one of the counties, which is Narok County of Kenya, which is in the southwest part of Kenya. And basically, our drive or motivation was frequency in floods, which are historical, which were highly linked to heavy rains in the region. And therefore, we had to see how we can provide a solution to this. And then moving forward, as you can see, we've been able to expand this to another county in Western Kenya, near Lake Victoria. For those who have never been in Kenya, Lake Victoria is one of the largest freshwater lakes in Africa, and one of the basins or catchments that supply or distribute water to this freshwater lake is the Yala and Nyando basin. So basically, the flood early warning is focused on using a dynamic model, or if you like, there is a WRF, or the weather research forecasting model, which in this case, we were using it to model heavy rainfall and flood and forecast the risk of flooding. And also we are using the GR4J model, which is more of a statistical model, but for hydrological flood forecasting in order for us to achieve our goal. So basically, Kenya is located in the eastern part of Africa, and it's one of the countries that are highly affected by climate variability and climate change, if you like. But in recent years, climate extremes, of course, characterized by issues like floods and droughts, have been very prevalent. Initially, we used to receive maybe a major flood or drought once in 5 years, but now it's almost every year we have to report this. And so as you can see on the right side, we have our focus counties, where figure 1, which is at the bottom here on the right, is where we have Narok County in the southern part of Kenya. If you can see my mouse where it's focusing on, and then the pointer, and then for the second basin, it's somewhere around the Lake Victoria basin. And you can see from the maps where we have the network of the the rain gauge stations, the automatic weather stations, and of course, also some automatic weather stations which are indicated. So the flood early warning that we envisaged actually is a modular system as depicted in the figure below, where we have the models, which of course we have a rain forecast model, we have a runoff forecast model, and of course a hydraulic forecast model. But we have largely been more into running both the rainfall and the hydrological forecast model based on the runoff. And of course, you can see that our data, of course, once it's ingested or fed into our models, we're able to run and produce some rainfall maps, as well as some, runoff or let's say the forecast based on the stream flow level. And of course, the level of the waters in the rivers or in the basin actually are an indicator of what thresholds we can raise an alarm with regard to giving a warning for flooding. So before I go back to what outputs we have within the fields, of course, we have been running the WAF model at a grid resolution of 5 kilometers, which is the main domain. But of course, we also nest these within 2 kilometers in order for us to get a more localized forecast using the WAF model. And in order for us to get the flood risk models, we use the historical data to define the flood risk levels depending on the amount of rainfall. And therefore, within 24 hours, if the rainfall is up to 20 millimeters, then we see a low risk of flooding in the area. But if it exceeds 20 millimeters to 50, then we see moderate. But if within 24 hours we exceed 50 millimeters of rainfall, then obviously we will see floods, whether we like it or not. That happens because from historical data, that's what we have shown. But for the GR4J, we more or less use rainfall as an input. But again, now WAF output, the output from what we calibrate from our model as a forecast, then we feed that into the GR4J model. And this gives us, the stream kind of level, which of course is an indicator of what flood will occur, the risk of flooding or not. And of course, the historical data, the GR4J, of course, uses another component, the evaporation, which of course we estimate this from rainfall and temperature. But before I move, you can see the activities listed there in terms of trainings. Most of these are in-house, but also we go out to do this across our stakeholders in order to improve the capacity. And as we move forward, we hope that within the World Meteorological Regional Training Center, where we have one here in Kenya, we can introduce this maybe alongside the courses that are provided so that we can provide the training across the region and in the country. So this is just a more detailed model structure of how the WAF model works. I don't need to go into this, but in a nutshell, you can see where we have our input with the terrestrial data. We have the meteorological data. And of course, we also have some observational data, of course, including from the satellite estimates and products. And then this is fed within this working engine here, I would call it. And then, of course, there is a pre-processing where you can analyze and then visualize some of this data set. And then you can get an output in terms of a map or a forecast. And below here, I've just indicated what I explained in detail about the thresholds, the daily rainfall amounts. When you exceed a certain threshold, then you can declare flood risk, like what you can see from this example here of daily rainfall. And then you can see here, at least there was a flood around this particular date. But within these other days, then there was less. But for the GR4J flood, of course, this is based on the interception of the rainfall, then the routing. We have a production store, which of course enables one to understand how the process goes on within the hydrological model. And then we use a number of routines within our R and Python script to run this, and eventually we can be able to get an output. And of course, we have these parameters which are fixed, and they are area specific depending on the topography and other characteristics of the region. So these are but some of the WAF model outputs. This is for Narok, and you can see the green coloration here as indicated on this legend on the right, is that where we have the deep green, then we have a lower risk of getting flooding. But as you move towards these other colors like the yellow and moving towards red, then there is a high chance. Like you can see the central part of the basin or Narok County, we must have declared some flood risk in those regions. And even within the blue area, there is a medium risk. And this was in 2024. On the right, you can see there is a map for the Mara Basin now, where you can see most of the areas there was no any risk of flooding, because around this time it was a dry season. This in the western region, that is in Kisumu, where we have the Yala Nyando Basin. You can see the red here around the counties of Nandi, touching parts of the neighborhood. Here, there must have been a high risk of flooding in those regions, with just medium when you go to the southern parts and the surrounding areas. On the right, we also started, working on the weekly rainfall forecast, which of course we can also declare the risk of flooding within these areas, but this is still under development for the weekly forecast. This is just but an example of the GR4J output for the Yala, which, as you can see, we calibrated this with historical data, rainfall data, and you can see there is some good correspondence between the observed and the forecasted or the estimated values. The challenge, as you can see, is in some of the areas we have missing data because of the nature of observing the meteorological parameters in those regions. However, we are still working on how we can improve the network around that region. And you can see that this gives us a good indicator in terms of how the flood can be mitigated using this particular model as we move forward into the future. And I thought it would not be fair to go away without showing how we communicate this information. Principally, we just been using the social media because it's fast. It's also very efficient, and it can also be used where you have people who have smartphones or mobile phones largely. And in Narok, we are using a WhatsApp platform with about 1,000 stakeholders or end users, if you like. And in Kisumu, because we just started this year, we have about 453 members. And we are looking forward to expanding this to using other modes of communication. And within the WhatsApp, we are also able to receive immediate feedback from the ground. And we are looking at where we can be able to digitize this information such that if a particular person communicates from a certain specific point, we can get the geolocations. And therefore, we can be able to link that to the actual event that happened. So largely, it's about the impact here. that we report to the members in those areas. Here I've just provided a link for communication and dissemination setup for Kumasi in Ghana, which I guess for the purpose of time, I might not play it out, but you can always have this link and you can watch and find out how they are utilizing the mobile technology in order to communicate the flood early warning in that part of Africa. So I just wish to acknowledge the project team, the TEMBO consortium partners, and also the KMD management. And from me, it's a thank you.